Hey guys, about to start ENGAA 2022 section 1 part B. So let's get started. Okay, simple integral. Let's just make this a bit thinner. It's going to be from 4 to 1, 2x squared minus 3 divided by x to the minus 3 over 2 dx. So the key with these questions is just to take it slow, to not make any mistake. Like do it in small steps. So here we go, that's 4 to 1. That's 2x to the 1/2 minus 3x to the minus 3 over 2 dx. And then when we integrate, increase the power by 1, then divide by the new power. So that's going to be 3 over 2, and divide by the new power, that's going to be 2/3. So increase the power by 1, that's minus a half, divided by the new power, that's minus 2. Then from 4 to 1, that's going to be plus 6 divided by x to the minus 1 over 2, 4 to 1, which is going to be 4/3 times 2 to the power of 3 minus 6 over 2 minus 4/3 plus 6. So anyways, here we go. It's going to be 7 times 4/3 minus 6 over 2, which is going to be 28 over 3 minus 3, 28 minus 9 over 3, which is going to be what? Is going to be 19 over 3. A. Okay. A stationary wave in a medium. Transverse wave at rate the stationary wave travel at speed of 300 meters per second. What's the frequency of the transverse waves? Alright, well we know the wavelength of the stationary wave is the same as the wavelength of the transverse waves. So that what's that going to be? That's going to be one wavelength, that's two wavelengths, that's three wavelengths. So 3 lambda equals 150 centimeter. So lambda equals 50 centimeters. And we know their speed, so we know v equals f lambda. So f equals v over lambda. It's going to see 300 meters per second over 0.5 meters per second over 0.5 meters. So f is going to be 600 hertz. So that's E. Diagram shows a semicircle of radius 5 units and a triangle. Okay. Expression in terms of x for the area of this triangle. So the triangle is going to be, that's the perpendicular height y. This is 10. So area is going to be half times 10y, which is 5y. Now we just y in terms of x. So we know, because this triangle has got center 5, 0, it's going to be, the equation for this is going to be plus y squared, and the radius is 5 equals 5 squared. And we know that it's only the upper half of the triangle, so we can specify y is greater than 0. So y squared equals 25 minus x squared plus 10x minus 25. So equals, 10x minus x squared. And then what that means is that the magnitude of y, which is actually going to be y because y is greater than 0, is going to equal the square root of 10x minus x squared. Yeah, so therefore A is going to be 5 root 10x minus x squared. a stone is thrown vertically upwards. Okay. So let's say, so we know energy is always conserved. So let's say from being thrown until reaching max height, we can say the change in kinetic energy, let's say for the Earth first, plus the change in the gravitational potential energy for the Earth, for the rock being thrown on the Earth is 0. And we also can say this for the Moon. Plus the change in the gravitational potential for the Moon. We know because the rock has got the same mass, so delta EK equals half mv squared. And the rock has got the same mass and is thrown with the same initial velocity on the Earth as the Moon. So these two are the same. So yeah, what we can tell is therefore that the gravitational potential energy, the change in the gravitational potential energy on the Earth must equal that on the Moon. So what that means is that the mass of the rock times g on the Earth times the max height reached on the Earth, which is just h, is equal to the mass times g on the Moon times the max height reached on the Moon. Let's call that h. And we're trying to find h, so capital H. So that's g over gm h, which is going to be what, 10 over 1.6 h, which is a. Four mathematically similar solids have the following properties: ratio of lengths and surface area. Okay, so this is all about this idea that, so let's say we've got this cube. So I'm going to show, let's say we've got this cube with side lengths 1, 1, 1, 1. And let's say let's scale up by increasing all the lengths by, we'll scale it up to increase all lengths by factor k. So now this is, this is k, this is k, and this is k. So we know the length scale factor, the factor is k over 1, which is just k. The area scale factor, so if we look at, let's say, this face, it ends up at k squared, and it was initially 1 squared, so the area scale factor is k squared, and the volume is k cubed. It ends up at k cubed, but it was initially 1 cubed, so that's k cubed. So what we can see is we've got this general relationship, and this is true no matter what the solid is. Like no matter what the shape of the solid is, the length scale factor, when you square it, you get the area scale factor, and when you cube it, you got the volume scale factor. This is true because of this idea that we can divide. This is like a key idea that we can divide. It's got to do with calculus. That we can approximate. We can better approximate any. We can approximate any volume by like a bunch of like small cubes, and then as we make the cube smaller, we get a approximation that gets closer and closer to the actual volume. So you can always represent any volume by just like dividing into a bunch of like infinitesimally small cubes. So anyway, all that to say that this is true for any shape. So I'll just move that all up there just so we can keep that in mind. Oh, dang it. Okay. So yeah, so here we go. So let's say K. We'll define KAB defined as length scale factor from A to B. If the A and B are similar solids like W, x, y, and z. So what that means is that kw, so we're looking at this first one, kwx is going to be 2 over 1, which is 2. And then that means the volume scale factor for kw and x is going to be k cubed, using this idea over here. It's going to be k cubed w over x, which is going to be 8. Okay, and then the ratio of the surface area of x to the surface area of y. So that means that the area ratio, which is going to be k squared from x to y, is going to be 1 over 2. So that means that k cubed x to y, so the volume scale factor, is going to be 1 over 2. So basically we can write that as 2 to the minus 3 over 2. Yeah. And then k cubed from y to z, volume scale factor, is going to be 2 over 1, which is just 2. So what that means is the volume of x is 8 times the volume of w, and the volume of y is 2 to the minus 3 over 2 times the volume of x, and the volume of z is going to be 2 times the volume of y. So we can get everything in terms of the volume of w. So that means that we've already got Vx in terms of Vw. So what that means is that Vy is going to be 2 to the minus 3 over 2 times 2 cubed, Vw, which is going to be 2 to the power of 3 over 2 Vw. So that's Vy. And then Vz is going to be 2 times Vy. I don't know why I wrote it like that. 2 times Vy, which is going to be 2 to the 5 over 2 times by Vw. So anyways, we've got to arrange these in increasing order. So yeah, we know that Vw is going to be the smallest. So we can write the coefficients. So write the coefficients of Vw in each. So 1. So that's for Vw. 1 is less than 2 to the power of 3 over 2, which is less than 2 to the power of 5 over 2, which is less than 2 to the power of 3, because 2 to the x is an increasing function. And 1 is 2 to the 0. So what that means is if we multiply everything by Vw, what we get is Vw is less than 2 to the 3 over 2 times Vw, which is Vy, which is less than 2 to the 5 over 2 times Vw, which is Vz, which is less than Vx. So if we arrange the increasing volume, we go y, w, y, z, x, which is b. Okay. A ray of light is incident on a boundary between a vacuum and a medium x. Features shown. Okay. So let's call this phi, let's see. So what we've got is, so this is vacuum, so that's going to be 1 times sine theta plus Snell's law is, let's call this refractive index n sine phi. But phi is actually going to be 180 minus 90 minus theta, because theta plus 90 degrees plus phi is 180 degrees, as you can see over here. So that's going to be n sine 90 minus theta. And 90 minus theta is just cosine theta. So sine theta equals n cosine theta, so n equals tan theta. So that's E. Okay. Okay, so we'll just have to expand that. That's going to be 4 plus 4 root 20 plus 20 over, we'll expand one of them, so that's going to be 1 plus 2 root 5 plus 5 times by 1 plus root 5. It's going to be 24 plus 4 root 20 is going to be root 4 times by root 5 over 6 plus 2 root 5 times by 1 plus root 5. And then we can take out a factor of 2 from both top and bottom. So that becomes 12 plus 4 root 5 over 3 plus root 5 over 1 plus root 5. 12 plus 4 root 5 over 3 plus 4 root 5 plus 5. 12 plus 4 root 5. Take out factor of 4. And then we've got to rationalize the denominator. Six minus root 5 minus 5 over what's that? That is minus 1. That's 1 minus root 5. Okay, A. Electric trains traveling on a straight line on track. Let's put it Q. Okay. The speed of the train is going to be this. Differentiate it, which is going to be 2bt. Speed train increases with time at a constant rate. Yes. We can see that that means the acceleration is constant, which is going to be 2b. So yeah. Resultant force acting on the train increases with time. No, because F equals ma. So this is the net force. Sorry. 2mb, so no, it doesn't increase with time. Then the rate which energy is transferred to the train increases with time. So rate at which energy is transferred to the train, that means the power at which the network is delivered. It's going to be the net force times the velocity, because they're in the same direction. 2mb, sorry, that should be x differentiated once, times by a plus 2bt. Yeah, so it increases with time because that's 2amb plus 4mb squared t, and 4mb squared is positive. So yeah, this is true. So 1 and 3 are the only true ones. Okay, let's call this S. So what we've got is that this, we can write it like this. So from I equals 2 to 4, we're summing up these 3 of these. Sorry. I to the minus r. So let's just think about this for a minute. We'll call that, let's call that S1. So S1 is geometric series because you multiply by the same thing, where the common ratio is I to the minus 1. And then the, what's it called? The first term is, so you plug in 2, you get I to the minus 2. So what that means is that the sum to infinity, so S1, which is the sum to infinity of this, is going to be, remember that if we've got a geometric sequence where it's like this, let's call that n to the minus 1. The sum to n terms, so that means, the sum to n terms is going to be over ui's. It's going to be a to the 1 minus r to the power of n over 1 minus r. And then in the limit as n goes to infinity, n going to infinity, this sum, which we'll call s goes to, s2 to differentiate from this s, goes to a over 1 minus r. So what that means is that the sum to infinity for this is going to be the first term, which is I to the minus 2 over 1 to the over 1 minus the ratio. So as we can simplify that, so it's going to be 1 times by I squared on both sides. So I squared minus I. So S is going to be 1 over 2 squared minus 2 plus 1 over 3 squared minus 3 plus 1 over 4 squared minus 4, which is going to be 1 over 2 plus 1 over 6 plus 1 over 12, which is going to be 6 plus 2 plus 1 over 12, which is 9 over 12, which is 3/4. So that's B. Okay. Okay. So we need to find the resistance of the other one. So let's say the other length of wire has resistance R2. So R2 is going to be, so we need to remember this formula. The resistance equals the resistivity rho times the length over the area. So that's going to be resistivity over the length of that's the cross-sectional area of the wire. The length of the wire over pi times the radius of the wire squared. So R2 is going to have the same resistance. Let's say this is for the first wire. So that's for first wire. So it's going to have the same resistivity. It's going to have double the length, twice as long, and it's got half the diameter. That means half the radius, half r squared. So what's that going to be? That's going to be 8 rho L over pi r squared, which is 8r. So R2 is going to be 8r. So the total resistance, because they're in parallel, is going to be what? 1 over r plus 1 over 8r minus 1, which is going to be 9 over 8r. 8/9 r. So that's B. Okay. So let's just expand this. We got x to the 4 plus 4x squared minus 21 has to be negative. So what's that? If we factorize that, that's going to be minus 3 times x squared plus 7 has to be negative. And this is a quadratic in x squared, so if we plot x squared over here, and then y over here, and let's say that's f of x squared, so this is f of x squared. Because it's got a positive coefficient, we know it's going to be like this shape instead of this. So what this implies is that if it's going to be negative, x squared has to be it has to be greater than -7 and less than 3. But x squared is positive anyway, so we say x squared has to be less than 3. So that means magnitude of x has to be less than √3. So that means x has to be between -√3, and √3. So that's A. Again, an empty bucket has a mass of 1.2 kilos. The hand that acts along a tangent to the circle radius 0. Okay, so that just means this force is always going to be perpendicular to the handle. Okay. Required to lift the bucket is wasted energy. Oh, so that means what's the efficiency of the system in lifting water from the water? Okay, because we only want to consider the energy used to lift water. Okay. Okay, so what we're going to do is let's think about what happens if we move handle through angle theta. Okay, so let's call this radius big R and this radius R. Then we'll call this the force F, which is 250 newtons. So the work we do, the distance it moves through is going to be distance handle moves is big R theta, if theta is measured in radians. So that means the work done to turn. So that's like input work. Input work is FR theta. Okay. So the output, then the change in the gravitational potential energy. So when we move through like an angle theta, let's say this is the angle theta. When it moves through, we need to figure out how high this bucket is lifted. We need to figure out this height h. So that height h is going to be the same as the distance. So because we need to consider the y is inextensible, it's going to be the same as the distance, like this rotates around, if that makes sense. So that's going to be, so h is going to be r theta. So the bucket is lifted by a height small r theta, and then so the change in the gravitational potential energy of the water is going to be the mass of the water times g times h, which is mw gr theta. So that's like the useful energy output. Useful energy output. So the efficiency is going to be the useful energy output, which is delta U G, mw gr theta, over the input work, which is F r theta, which is going to be, so we can cancel the thetas. So what's the mass of water? It's going to be the volume times the density of water, the internal volume, which is 0.015 meters cubed. times the density, which is 10 to the 3 kilograms per meter cubed, times G, which is 10 newtons per kilogram, times small r, which is 0.2 meters, all over Fr, which is 215 newtons, times big R, which is 0.6 meters. So because it's in standard units, we'll get efficiency in standard units, which is dimensionless, because it's energy over energy. So this is what we get. We get we get 15 times 2 over 25 times 6, which is, cancel that as a 3, take out a factor of 3 there, take out a factor of 5. So efficiency is 1 over 5, which is 20%, into 3SF. Okay. Sector of a circle that has perimeter 24. So let's see, this is it, this is theta, radius is r. Okay, so perimeter is 24, so that means, let's say theta is in radians, so then we can say this is r theta. And the area is going to be theta over 2 pi, that's pi r squared, which is half theta r squared. So yeah, this means that theta equals 24 minus 2r over r. So A is going to be, what's that? That's going to be 12 minus r over r times r squared, which is going to be 12r minus r squared, which is going to be minus r minus 6 squared plus 36. So that means when r equals 6, a equals max. There we go. Uniform meter rule is a mass of 100 grams. It's 1 meter long. Okay. So there's going to be, it's 20 grams over here, 80 grams at the end. Then the pivot, let's say x centimeters long. And we know that halfway along, we've got the weight. So this is going to be 50. And this is also 50. And we know we've got 100 grams weighing down here. Okay. We've got the pivot pushing up with a certain amount of force F. So let's take moments about 0 centimeter mark. So yeah, let's say this way is positive, this way is negative. So this 20 grams is not going to produce one, but we are going to get one from the pivot, which is supporting the 100 gram weight and also the 100 extra grams of the 80 plus 20. That's at a distance x, and the rest of them are producing clockwise moments. So that's 100 times 50 because of the weight at the center. The 100 grams weight at the 50 centimeter mark, and the 80 grams at the 100 centimeter mark. And because it's in rotational equilibrium, the sum of the moments is going to be 0 around every point. So, and notice I haven't done forces, I've just done the mass in grams. But it doesn't matter because if I did the forces, I'd multiply all the terms by the same constant. So, like, you can just imagine I've already divided by it. Minus, let's divide by 100, let's divide by, so that's 2x minus 50 minus 80 equals 0, so 2x equals 1, 30, so x equals 65 centimeters. So that's E. Okay. Curve this. Is the x-axis A and B. I know it's like this because the coefficient of x squared is 1, which is positive. It's got minimum at C, and C lies on T, so this is the rectangle basically. Okay, so I'm going to try to find what the minimum is. So I'll rewrite it like this, which is minus. So therefore, minimum value of y is minus 25 over 4. So this is going to be 25 over 4. Now let's find the intercept. So y equals x minus 3 times by x plus 2. So this distance is going to be, if that's minus 2 and that's 3, it's going to be 5. So the area 25 over 4 times 5, which is going to be 125 over 4, which is going to be 31.25 d. Okay, circuit present changes. We've got this, basically this circuit. And what do you want to find? Magnitude the direction of current in the 3-volt battery. Okay, so this is what we're going to do. We're going to apply all of Kirchhoff's laws. So for now, we're just going to assume the directions of the current. So let's say this is, we call this I, small I, call this big I. Look at Kirchhoff's law, this is going to be this way, and that's going to be well, not necessarily that way, but let's just choose that way. And if we get anything wrong, like the direction of any of the currents wrong, then it'll just be negative, so don't need to worry. So we're going to apply the voltage law, how if you go around in a closed loop, then the voltage always sums to 0. So we'll do, which loop should we do first? Let's do this loop first. Do this loop first. So what we're going to get starts over here, so we go up, so that's plus 6 volts. Anyway, I won't write the volts. Plus 6, and then we go the opposite way across this battery, so we're going to go down minus 3, and then we're going to go over this, so that's IR minus I times 1 times 1 is 0. So what that means is that 3 equals I. So I is 3 amps, and it's positive, so we've got the right direction. Okay, next let's do, let's say, this loop. So we're going to again start over here. So what we get is we go the normal way over the battery, then we go over this. So that's going to be minus 3 times I plus I, and then minus, we go over this one again, so that's going to be minus I times 1 again, and that equals 0. So then plugging in I equals 3, we get 6 minus 3I minus 4I equals 0. So 3I equals 6 minus 4 times 3. So I equals 2 minus 4, which is minus 2 amps. So that means, so this is minus 2 amps. So what that means is that the current in here actually goes this way, and it's 2 amps. So the direction of the current is from Y to X, so these, and it's 2 amps, so that's F. So these sorts of questions are actually very simple. All you need to do is apply the 2 Kirchhoff's laws, and you need to remember that the voltage, like So that means around any closed loop, you can just, if you don't know the direction of the currents, just guess. Like I just randomly assigned these directions. Had no idea. In fact, I got this direction wrong. So just guess the direction of the currents, give them a label, and just remember that when you go like from, oh flip, I did it the wrong way. No, I did it the right way. So yeah, when you go from the negative terminal to the positive terminal of the battery, like over the battery, through the battery, then you gain the voltage. So that's going to be a plus 6 volts jump. But when you go this way over the battery, so let's say when you go this way over the battery, like from the positive terminal to the negative terminal, you're losing voltage. So that's going to be a minus 3 volts jump, regardless of which direction, regardless of whether the current's flowing this direction or this direction. It doesn't matter. Yeah. Just to specify that means regardless of which way the current flows in here, so whether it goes that way or whether it goes that way, when you go this way, you're losing minus 3 volts when you're applying that voltage law of cut. I can't remember which number it is, 1 or 2. When you apply that voltage law, when you go this way over the battery, you lose 3 volts. When you go this way, you gain 3 volts. So if I was to, anyways, I don't think that needs more explanation. Okay, straight line passes through the points 2A and A. Okay, here we go. So this is a setup. We've got, let's call this A, so that's 2A, 0, 2A, A. We've got B, which is A, 0. A line going through them, we've got P up here. Then let's call this point Q, and this is a perpendicular. We want to try find the length PQ. Okay. So this is what I'm going to do. I'm going to find PQ. I'm going to find the vector PQ, and I'm going to find the vector AB. And from that, I can find the gradients of those two lines, and then I can because they're perpendicular, we say when they multiply together, it's going to be minus 1. So let's first find OQ. So we know OQ is going to be OA plus AQ. It's going to be OA plus some real number K times AB, because AQ is parallel to AB, because Q is collinear with A and B. So AQ is just a scaled down version of AB, so K is going to be less than 1. Anyway, so that means OQ is going to be OA, which is 0 to A, plus K times by AB is going to be A0 minus, so that's going to be KA over 2A minus 2K. So that's OQ. So that means PQ is going to be OQ minus OP, which is KA 2A minus 2KA minus A2A. So that's going to be K minus 1 over minus 2KA. So that's PQ. And then AB, as we said before, is A minus 2A. So now we can find the gradients of these lines PQ and AB. So let me just make some space. AB, the gradient of AB is going to be minus 2A over A, because I'll tell you why. Look, minus 2A is the change in Y, and then A is the corresponding change in X. So the change in Y over change in X is minus 2A over A, which is just minus 2. So that's the gradient of AB. And we can do the same for PQ, so gradient PQ is going to be minus 2k over k minus 1. And then because the PQ and AB are perpendicular, PQ and AB are perp. So when we multiply them together, their gradients I mean, we get minus 1. So that means 4k over k minus 1 equals minus 1. So making space again. I caught that one accidentally. So what that means, so what's that? That's 4k so k has to equal 1/5. Yeah. So anyways, that makes PQ. That makes the magnitude of PQ, which is this, what we're trying to find. That makes it root of a times y, root of k minus 1 squared plus minus 2k squared, which is going to be a times y, the root of, what's that? That is 5k squared minus 2k plus 1. So PQ is going to be, I need to make space again. So that's going to be a times y, 5 times 1/5 squared minus 2/5 plus 1. This will be a times y, 1/5 minus 2/5 plus 1, which is going to be, what's that? That's equals square root of 4 over 5, which is 2a over root 5, which is 2 root 5 over 5a. So that's distance PQ. Okay. That means they like stick together. So let's say the final velocity is v to this direction. Let's just guess. If it's not, then we're going to get a negative value. So anyways, so conserve kinetic energy. So we get 4mv minus 2mv equals the total mass, which is 3mv. So now we can find v, which is going to be 2mv with 3m. So it's going to be 2/3 v. So it's positive. So it is actually in this direction. So we guessed right. So the loss in kinetic energy, so the change in kinetic energy is going to be half times, so that is the final kinetic energy, total mass, which is 3m, times the final velocity, which is 2/3 v squared, no, that should be squared, minus half m times 4v squared minus half times 2m v squared. So that's going to be 2/3 mv squared minus 8 mv squared minus mv squared. It should be 2/3 minus 27 over 3, so that's 9 squared, which is going to be minus 25 over 3 mv squared. So it loses that much kinetic energy. Okay. Okay, so this is going to be, yeah, I think I spotted it, a quadratic in root 2x. So let's say, yeah, so this is going to be root 2 squared to the power of x minus root 2 to the power of 6 times by root 2 to the power of x plus 12 equals 0. So that's going to be root 2x squared minus, what's that? That's going to be 8. So root 2 to the x plus 12 equals 0. So what that means is that root 2x, 2 to the power of x, sorry, minus 6, root 2, minus 2 equals 0. Root 2 to the power of x equals 2 or 6. So if we square both sides, we get 2 to the power of x equals 2 squared or 6 squared. So that means x is either 2 or x equals log base 2 of 6 squared, which is 2 times the log base 2 of 2 times 3, which is 2 times log base 2 of 2 plus 2 times log base 2 of 3, and that's just 1. So the sum of solutions is 2 from here plus 2 log 2 3. That's the other solution, which is going to be 4 plus 2 log 2 3. So that's f, and then this.
Thank you for watching, everyone. Hope you found it useful. And for more ESAT practice and preparation resources, make sure to check out our website. Link will be in the description.